Okay, so today we're going to talk about congruent triangles. Triangles that have the same size and shape are congruent. This is in our ISN, page 5. Two triangles are congruent if, and it is on your worksheet too, so don't be confused. Make sure we're doing the ISN right now so you've got your notes. Two triangles are congruent if and only if all three pairs of corresponding sides are congruent and all three pairs of corresponding angles are congruent. In this figure, this statement saying that ABC is congruent to triangle ABC congruent to triangle RST. This is called a congruent statement. I find that, I don't know why that little dot's there, the congruent statement. That's very important that you know what you're being asked when it says to write a congruent statement. Okay, so congruent statement, again, can't stress enough when you're asked what is it, you're going to be writing one of these, all right? And you have to do it in a certain way. So if you choose the first triangle's letters, ABC, why did they write RST? Well, there's a good reason. And that's the only way that they could write this congruent statement. If they start with ABC, it had to be RST because when you start at A and go then to, B, you are going from a single marked angle to a double marked angle. Now look at this triangle. Single arc marked on the angle is at R. And then they went to the double marked angle, which is at S. Now, when they went A to B and then to C, they ended at the triple marked angle. Do you see what I'm talking about? So over here, we ended at T because we needed to go from R to S to T so that the order was the same as A to B to C. You see what I'm talking about? Order of your statement matters. If the person had started with, say, BCA, then it would have been STR. Okay, so whatever you decide. So I'll explain that more as we practice writing them today. All right, so let's go on to the next part. Third angles theorem. This third angles theorem says, well, yesterday we learned that the angles of any triangle add up to 180. So if you have knowledge of two angles and two triangles being congruent, then if two angles of one triangle are congruent to the two angles of another, a second triangle, then the third angles are also congruent. Why? Well, if you know two of them are the same, the third ones would come from doing the same mathematical operation. So in this diagram, angle C would be congruent to angle F by the third angles theorem. We will be doing proofs next week. We're going to be starting to look at proof again, and we're going to be proving that triangles are congruent. So this might be a way for you to say some angles were congruent. Right? Anybody still need this? Okay. So now we have an example that says this here is a congruent statement. The triangle congruent statement must be in corresponding order. The letters must correspond to the angles that match up. So in this case, it's saying that angle X is congruent to angle R. Okay, so over here, I'm going to mark that. Angle X congruent to angle R, and I'm going to write that in this statement. Angle X is congruent to angle R. You can tell right from the congruent statement that angle Y would be congruent to angle S. Yep, angle Y congruent to angle S. And then I'll go mark it on the picture. Double arc, double arc. And finally, we can say that angle Z is congruent to angle T. And I just threw some color in there. Triple arc, oops, triple arc. You can also list the corresponding pairs of sides, and you can get those from the statement as well, if they're triangles. XY congruent to RS. See that? XZ, first and last, congruent. Watch where I'm pointing, please, because this is something you're going to have to learn how to do, and you're going to need to do it. XZ, first letter and last letter. Over here, it's RT. That's where they can get that statement, okay? You don't even have to look at the picture if you have the congruent statement. And then YZ, last two in this order, Y to Z, Z, S to T, not TS, but ST. That's why it's all perfectly aligned, okay? So let's move on to CPCTC. You are going to need to know what CPCTC stands for. Okay, so we're going to recite it, and we're going to memorize it, and we're going to say it a lot of times. CPCTC is a little bit of a mouthful, and it stands for quite a long thing. Here's what it talks about, and then I'll tell you what it means. Two triangles are congruent if and only if their corresponding parts are congruent. Corresponding parts would include corresponding angles and corresponding sides. The phrase if and only if means that both the conditional and its converse are true. So for example, if I said, if it's a frog, then it's green, the converse would be if it's green, then it's a frog. And then it would say if it's an animal is a frog if and only if it's green. Converse and conditional statement being true, that's where an if and only if comes in. It means the converse and the statement itself are both true. For CPCTC, this means that corresponding, that's the first C, parts, corresponding parts of, what are we talking about today? What kind of things? C and then a T. Any guesses? Congruent triangles. Yep. It's nice to try to guess what it is so you remember it in the end. Corresponding parts of congruent triangles are, what do you think that last word is? It's already been repeating a word. Congruent. Corresponding parts of congruent triangles are congruent. That is what CPCTC means. Oh my gosh, I wrote kind of big and squeezed it all the way over to the side. This can be used to prove triangles are congruent when all 6 pairs of corresponding parts are shown congruent. We're not going to do proofs like that. That is what I've taken out of this thing. Okay? I've taken it out. We will be using it. We're going to use this to prove parts congruent after the triangles are proven congruent. Okay? We're going to be using in our proofs at the very end. So we're going to be proving triangles congruent by some other methods that I'll start teaching you on Monday. And then at the end, we can say the rest of the parts are congruent by CPCTC. All right, that was the end of the ISN. So now we're going over to the packet that you picked up as you walked in. 4.3. This is not a real long lesson, and you're going to have some time to work at the end. We're going to be repeating a few things. Do you have a question? Okay. Triangles that have the same shape and size are congruent triangles. You've got a few things to fill in at the top on your worksheet, right? 2 triangles are congruent if and only if all 3 pairs of corresponding angles are congruent and all 3 pairs of corresponding sides are congruent. I just did it in a little bit different order. I said sides than angles last time. Doesn't matter. In this figure, which is the same as what was in our ISN, ABC is congruent to triangle. ABC is congruent to triangle RST. Do you need me to explain something again? Go ahead. No, if you have something you want to say, go. I'd love to answer your question. No? Okay. Third angle theorem. We've already stated that if Two angles of one triangle congruent to two angles of the second, and the third angles of the triangles are congruent. So you have this word to fill in again. Again, we already said this in the ISN, so I'm just going to quickly say that the measure of angle C would equal the measure of angle F by the third angles theorem. I abbreviated theorem this time, THM. Okay, does anybody need this still? Because I was kind of going quick here because we already did this once. Here we go. Number 1, finally. It says, show that the polygons are congruent by identifying all congruent corresponding parts. All of the corresponding parts. And we only have to do that for number 1 and number 3. Then write a congruent statement for each pair of triangles. So we're going to always write the congruent statement, but only number 1 and 3, we're going to write out all the parts. All right, so let's go ahead and start with the angles. So you look at the first triangle and say angle A. And you go look over at the other triangle, what angles mark the same? Yep, angle J. So angle A is congruent to angle J. Now I'm going to go for another pair of angles. Angle B is congruent to angle, go over to the other picture, double arc, K. And last pair of angles, angle C is congruent to angle L because there's triple mark on C and triple mark on L. Are we all cool about how to figure out what angles correspond and are congruent? Okay, now I'm going to go for segments. So I'm going to start with AB. Segment AB is congruent to segment, and I said A, then B, so I'm going to say J, then K, because that's the one that matches up with it in the second triangle. I have side BC, which is a segment congruent to, in the other triangle. If I start at B and go to C, I would say KL. And lastly, if I said AC, side AC, segment AC is congruent to segment JL. Okay? Any questions about how I labeled those? Or why they're the ones that match? Okay, now I need to write a congruent statement. The congruent statement says that a triangle is congruent to another triangle. The triangle that I'm going to name, if I say triangle ABC, which we tend to do, it would be congruent to triangle what? Now you have to go in the correct order. And it have to be JKL. All right, do we all, I hope if you understand what's going on right now, it's going to be really helpful that you've been focused and you know why I wrote these in this order. Okay? Because I can make this very easy chapter. Let's try number 2. All I'm going to do is a congruent statement. You're going to have to be much more careful on this one. We always tend to do the ABC thing, right? All right, so I'm going to go for it. And then after that, I'm going to start asking you guys to just randomly tell me to name a triangle. Because I want you to know that there's more than one way to write it correctly. Okay? So if everybody didn't go ABC, the way I wrote the first triangle determines how I write the second one. Okay, so I started with A, which had a single arc mark. So what do I have to start with on the other triangle? B, okay? All right, I then went to B. Now notice how B, the angle right here is marked. It's not really angle B, it's angle ABC. What angle does it match up with in the other triangle? Yes, it's down here. So we went that way. So here we're going to have to go this way. So it's going to be DC, and then we went AB, C, the triple marked one. So we will end at the triple marked angle, which is at B in the other triangle. All right, is anybody confused about that? Because it can be a little confusing when they're twisted. Like if you wanted to take this triangle and put it on top of this one and have it match up correctly, you would have to this off and turn it quite a bit, right? You'd have to flip it over, right, and slide that piece on there and this piece on that, okay? It's got to match up right. All right, let's try number 3. We're going to be writing down the parts, okay? So on this one, I got to warn you, there are going to be some angles that cannot be single letters. So let's start with the angles. I can do angle J congruent to angle L, okay? Because these guys are, oh, my pen's stuck, and I don't know why it looks like an eraser today. It does that often. All right, that's the last time I can just use one letter, because the rest of them are attached to each other. If I go up here and name that angle JKM, now I want to correctly name the other angle that would be congruent to it. Is it up here or down here? Parallel lines, you see the Z? And the N. Alternate interior angles are congruent, so it would be here and here. Are you with me? It's not up there. It won't be here because that's smaller than that one. I hope you can tell these are the ones that are congruent. All right, that I said was JKM. How am I going to name the other one down here? It'll be, I started at J, went to K, then to M. L to M to K. Okay, LMK. This is real important. Okay. Now I'm going to go to this angle and this angle. So I'm going to call that top one LKM. And it would be congruent. How am I going to name it? I started with L, went to K, then to M. So on the other figure, I have to start at J, go to the angle M to the K. JMK. Sounds like a restaurant. Nobody knows what I meant. Some people do. JMK Nippons. All right, I just was making a joke. Wasn't very funny, though. All right, so now I'm going to name the congruent sides. Okay. JK. Yeah, just kidding. Right here, let's go from here to here. Okay, careful. So if I said JK, I have to go over here and I'm going to go, and I'm trying to be really nitpicky right now to get you used to corresponding parts. See where the J is, it's matching up with the L part. So it would be JK would be congruent to LM, and I heard you say that. All right, now let's go, I don't care, JM, congruent to, I went from J to M, so I'd have to go LK. Got it? And finally, oh, wait a minute, KM is congruent to, wait a minute, what would happen if I chopped these apart and turned it? I'm just being real nitpicky right now. I would not mark it wrong if you wrote KM is congruent to KM. But I think that a lot of you can understand that it's really not KM anymore. It's MK. Because if you took and turned this thing, the K is going to drop down over here onto the M, and the M angle, that's going to go on to the K. You see it? If you were to turn the triangles. So it is actually MK. I will not, again, mark that wrong if you don't flop the letters, okay? When we do a test. I'm going to take that. You know what it's going to be? What's the property that says KM is congruent to KM? Something's congruent to itself. Remember that name? It's the reflexive property. We are going to be using those again. And it's a good thing because we need to make sure we've kept those in our brains for finals. Pardon me? Oh, yes. final exam, you will have a review. Absolutely. And the key will get sent out, etc. All right. Write a congruent statement. That's all we're doing now. All right. You don't have to write all the parts out. So let's go. Somebody give me a way to name the first triangle. All right, Carolyn. FEG. Okay. And the reason I asked someone else to do it, I didn't want you to presume or assume that it's got to be any particular order for the letters. It doesn't matter. What matters is if I write FEG, then I have to write the next part a certain way. Okay? So, and for me, unless I lead you, I have to read everything that you wrote and make sure it matches up properly. Okay, so she started with F, which is where? On the other triangle, it's at K, where the right angle is. Okay, let's see if you did it right. And then she went to E, which means she went down the side that's marked with a triple mark. So over here, you'd have to go K, then to J, okay? And then there's no other choice for the last letter. It's L. So F to E to G is matching up with K to J to L. You can use the arrows if that helps you. All right, 5. Give me a triangle. Sound like I'm cheering. Give me a A. Sorry. Name me a triangle, please. Thank you. He made a word. All right, cab. CAB. Thank you, Dakasha. All right, CAB. I like that. All right, where is C? So she's talking about this bottom triangle, starting at C, went to the A, and then to the B. Pay attention to the markings. I got a triple mark angle, then a double mark side, then a single mark angle. I got to find what matches up with that. What is it? B, okay. B is where the triple is, and then there's a double mark side and a single, yep, B to D, and then to C. That's it. Oops, I need a triangle symbol. Okay, if you're understanding this, this is going to be very good then. Now that one was flopped over. It was tipped over too. It was twisted. This one's not. Okay, how about give me a triangle, please? UTS, okay. Why not? All right, so we went from U to T to S. So how do we got to go on the other one? URS, yeah. We are learning to make congruent statements. Okay, I am going to leave these for you. Let's go over, though, actually, should we just, there's not a whole lot in this packet, right? I'd like you to do these, should we do them together? No? Okay. I wanted to help, though, with 9 and 10. Show you how to do some algebra problems on there. All right, so let's look at number 9 and 10. The first thing you do is you say, okay, well, number 9 says to find the value of x. And I don't believe that's number 9 on yours, is it? Is yours say this is 7 and this is 8? Okay. I told you I took a lot of stuff out of this packet because I didn't like the way this book did things. So I've changed it. Okay, can I change that? You guys said it was 7. All right, and this one was 8. All right. Well, if I'm going to find x, I go over to find where an x is in the problem. I see 2x plus y. I see a congruent statement, and that's on EF. Okay, segment EF corresponds to what segment on the other triangle? So you can use the statement up here. It'd be BC. So I go find, oh, there's the BC. All right, so these correspond, which means that, wait a minute, 2x plus y equals 90.6. How am I going to solve that? I have no idea because there's 2 letters, 2 variables. we need to find out what y is so I can figure x out. So we're going to go and do number 8. We're going to find the value of y first. So then I see where the y part is. 2y minus 5 is labeled on angle D. Okay, that's on angle D, which corresponds to angle A. So that would correspond with that. So I know that 2y minus 5 is equal to 65. So I go ahead and add 5. I get 2y equals 70. I divide by 2. And you guys already got y is 35. All right. Now that I know y is 35, I can go back now and do number 7. 2x plus 35 equals 90.6. So I subtract 35 from both sides, which leaves me with 2x is how big? 50, isn't it 0.4? 0.6? Yeah, 55.6. Is that correct? Yes, okay. Then you got to divide that by 2. So we're going to get a decimal, no doubt. 27.8. All right, we just found all our solutions. Now, there's one more I would like, well, I want to show you something on here because this is a polygon, not a triangle, right? It has 4 sides. It's actually a quadrilateral. What matches up? So you can use the letters. So if you're trying to figure out what x is, you're going to use the fact that angle A corresponds to what? Go over to the statement. P. All right, so I'm just going to set up 2x plus 4 equals 100. All right, and then let's look at how to solve for y. Y is on side DC, and that corresponds to, yep, SR. So it corresponds to the 12. So all we're using is these parts, 3y minus 3 equals 12. And there's one more I'd like to work out with you, and that's going to be the last one. So please flip to the back page. I'll complete my recording, and then I'll be able to help out while you work. Oh, we didn't fill this in. Do you have to fill this in on your paper? You don't have a place for that? Sorry, I think I have it in a wrong place, don't I? Sorry, I forgot. Let's fill this in. Okay, let's see if we remember. Here's some prove triangles congruent, 2 triangles congruent if and only if their corresponding parts are congruent. So CPCTC means corresponding parts of congruent P4 triangles. You better not forget that one. Are congruent. CPCTC. CPCTC. I'm going to say it over and over. Corresponding parts of congruent triangles are congruent. I've actually heard corresponding parts of congruent polygons are congruent. But we're going to do triangles. Okay. The one I wanted to do with you, oh goodness gracious me, oh my, oh, I think it, oh, I'm going to use this grid right here. I believe you already have a triangle that's drawn. Okay. Could you tell me, well, actually, I'll look on my paper that I have here. I'm going to plot the points of the triangle. Just ignore this stuff up here. I don't get that out of here. I don't want to. All right. So this is number 11 on yours. I don't think I have this one in here. Okay, never mind. Okay, back here. What you have on your worksheet is a triangle that's already been drawn for you. It has points at 0, 4, 2, 2, and -4, 2. And then it's nicely laid out. What I'm going to do, it says to reflect it over the what? X-axis, okay? The x-axis is the horizontal axis, which we should know by now. And we're back to doing something from chapter 9, which is, we did things in a weird order. So if I flip B over the x-axis, B is 2 above, so I count 2 below, straight down and put B prime. C is 2 above, goes 2 below, straight down, and A is 4 above, go 4 below. All right, you guys are really pretty good at reflecting these triangles. Now, what the question is are these triangles congruent? And they certainly are. Yes, why are they? A reflection is a what? What's it called when they stay the same size? Do you remember? Rigid motion or isometry. A reflection is a rigid motion transformation. The angles and sides stay the same size. Okay? Now, if you reflect it over the y-axis, would the triangles be congruent? Yes, all reflections are a rigid motion transformation. Do you remember other transformations that we did that are also rigid motions that the triangles would be congruent? Rotation, yep. What else? Translation, which is a vector translation. Okay, sliding. And then the glide reflection also, but we really didn't emphasize that. Okay, that was all that I wanted to help you out with, unless you guys ask me some more questions. So over and out on the lesson today, and then you've got some work time.